So in statistics, we have how to present data. We have what we call measure of central tendency, and we have measure of dispersion. So we have measure of central tendency and measure of dispersion. So I'll just give you an overview. What is measure of central tendency? That means how can you use statistics to get the middle value of something? Do you get? How can you use statistics to get the middle value of a group of data? So how do you statistics to get the middle value of data? There are three major statistical tools we use. They call them tools. We have mean, median, and mode. That's one. Number two, we also have measures of dispersion. From the word disperse means something is scattered. I hope you can hear me clearly. Disperse means something is scattered. So how can you know how scattered the data is? For example, the example I gave earlier, you are 200 in your class. I don't think that's possible. Okay, let me use something realistic. Let's say you are 30 in a class, maybe in science class, and your marks, maybe you guys did a math class or a math exam or test, and you guys are having 40, okay, let's say over 40 in the test. People are having 10, 5, 25, 35. Some are having 38 and 39, or some is having 40. So dispersion means how close are the results together, like how close is, like maybe the teacher wants everyone to have, let's say your teacher is not so nice. Out of 40, he's saying that okay, let's say you guys should have let's say at most you people must not pass 25 over 40, for instance. So this is the thing is looking for. So maybe someone is now getting, people, all of you are now getting let's say 5, someone is getting 15, someone is getting 19. If people are not close to 25, that means I would say the thing is dispersed. It has a large dispersion or variation. So what are the tools we use for measures of dispersion? Because it comes out in objective a lot. We have standard deviation, that's known as your SD. We have variance. Do you get? These are the major tools they use in measures of dispersion. So looking at measures of central tendency, as I told you earlier, we have grouped and ungrouped data. Grouped and ungrouped data. So looking at group data, for group data, mean. Can someone tell me the formula for mean for a group data? Do you know I told you that you can get all the formulas in your formula table, so I'm not here to tell you how to cram formulas. I want to teach you how you can use them effectively in your exam, because there is no way you escape statistics. There is no way. So for mean, we know that mean is summation f of x divided by summation f. Now what you have to understand is, let your formula be your guide. That's what I tell my students. Let your formula be your guide when you are forming your table. You just get the formula in the formula table, or if you've crammed it in one way or the other, just make sure you have the formula somewhere. Then when you have the formula, listen carefully. When you have the formula, write the formula somewhere.
Away.
Then use the formula to, have I gone far? Not gone far. Use the formula to get your table. It's very important. Let the formula be your guide. So for instance, I'm a student now. I know that I want to get the mean of a number. Okay, let's say we are using assumed mean, for instance. No, there are cases whereby we use assumed mean. What is formula for assumed mean? When you are using assumed mean, the mean is always equals to the assumed mean plus summation of fd over e of f. So what is the d? Your d is equals to x minus the mean. So these are just a few things you need to know. What is the x? The x is your data. Now I want to get mean, e of fx over fx. I know that okay, my table must contain f, because I'm saying f here, and it must contain fx. So for me to have fx, I must have x, because fx means f times x. You get me now? So what is summation? Summation means the addition of all those data I have here. Like I said, let's say all of you, the marks is over 40, and let's say you have 5 in the class, and you guys are having, let's say someone at 25, another person at 35, maybe someone at 30, another person at 17. Okay, let's say you have 4 in the class. Now the number of those, you have 40 in the class, the number of those that have 25, maybe they are like 10. These ones they are like, let's say, 21. So let's say these ones they are like 9, and you have, let's see, okay, let me reduce this to 8. So let's say this is 8 and this is 2. I just want to get the logic. Then you kind of multiply them. So your formula is your guide. Now if you are looking at median for a group data, because what will be the median of a group data? That's when you are looking at class boundaries. So for statistics, when you are looking at group data, there are many terms we use class boundaries, and when we are using class boundaries, we use lower class boundary, which is shortened as LCB, and we use what? Upper class boundary. What is lower class boundary? For example, I said, okay, those that add, okay, I can group people in your class. Maybe someone had from 20 to 25 is one group like that. Another group is, let's say, 26 to, give me number, 30 years. Then we have 31 to 35. So this should have been 21. So like that, we have what again? 36 to 40. So can you tell me what is the C, the class interval? So once you tell me what is the class interval, that means the difference between both of them. You know what the class interval is? Are you there? Because if you check your 4-figure table, the formula for mean is what? Is the lower class boundary of the median class plus n. What is n? N is summation f of cumulative frequency before the median class divided by the frequency of the median class times c. So your aim is, I need to know all these parameters and present them in form of a table. Then from my table, I'll be able to solve. Hello, can you hear me clearly? So I'll know if you are still there. Okay. So can you hear
Yes,
me?
sir.
Alright. So I said, what is C? What would be my C in this, like this example I gave you? Because we'll be solving a real question very soon. So what would be my C? Like we have 21 to 25, 26 to 30. What would be my C? C is just the number of data that fall between the boundary. I'll repeat myself. Is the number of data that fall between the boundary. People that add 21, 25 means there are people that add 21, 22, 23, 24, and 25. That's 5. So the class limit or whatever is 5. So you know that here your C is 5 if you are dealing with median. Now what is lower class boundary? It means in your data you have the frequency, which you use and get n. N is always summation f. Get that clear? N is summation f. So I know that, okay, let's say I want to get the median class. Let's say the summation f or whatever is 40. Okay, let's do this way. I'm still using this frequency 8, 21, 9, and 2. Now the middle number of 40 will fall between what? 20. Am I right? So if here is 8, 8 plus 21 here is what? Is 30. So here is 30 means 20 falls between this number. So the frequency of this median class here, f of m, is equals to what? Is equals to 21. That's the frequency of the median class. This is the median class. Now let me get my LCB. Here LCB means you subtract 0.5 from 26. When you subtract 0.5 from 26, it's not actually minus, it's just.
Hey.
What is the problem? Your internet connection, Abby?
Yes.
Yeah, sorry about that. Okay, I'm talking about median here actually. Like I'm trying to just explain how you use the formula, because I'm not here to teach you gram formula, this and that. There's no even point doing that. So I'm just teaching you how can you use the formula to get your stuff effectively. So here we've mentioned L1. L1 means lower class boundary of the median class. Now this is the median class. How did I get the median class? I'm using the same frequency we used in the former table. So the total f, which is also known as n, the summation f is 40. To get the middle of a number that is even, you know what to do now. You just divide by what? By 2 to get the middle number. When I divided by 2, 20. I will not say because of here is 21, I will not pick 20. No, it is a cumulative something. You add them up. 8. Okay, let me use my mouse. 8 here plus 21 gave me what? 30. That means 20 has fall between from 9 to 30 in this place. So that means my frequency of my median, if I'm using this formula, because you have to know the meaning of each parameter in the formula before you use them. The frequency of my median is 21. Now, the cumulative frequency before the median class, CFB, should be what? 8, because this is the only frequency we have before the median class. Here will be what? 40 over 2. L1 is what? 25.5. So you see that even this kind of question can come out in objective, and you might be feeling like this wickedness, like it's a theory question. No, do you get that now? So I think, do you understand the interpretation before I move to mode?
Yes, I understand.
Okay, great. So let's move to mode quickly because of our time and other things we'll be looking at. So looking at mode, because I want us to solve question, I'll be doing other things. So looking at mode, yeah. When we use mode, what is our formula? Our formula is lower class boundary of the modal class. Modal class. What is modal class? The number that appeared most. Hey, I've rubbed up the stuff. Okay, let me do something. I think I can have it back. Okay, because I need this, so I think I'll rub this off instead. So since we've written the formula, because I need this. So modal class, now we are on mode. What is mode? Mode is what? A1 plus, have you seen this sign before? Can someone tell me what this sign is? Because the before we got table might be different, but I think it's the same thing. What is the meaning of this sign? Let me
Which
know.
sign?
This sign here,
Change.
this delta, it's called delta. Here is change. Though in Greek alphabet it's called delta. It can also be written like this. So it's like delta. Alright, change. So what is change? Change means, change in one means the difference in the frequency before the modal class and the frequency of the modal class. What do I mean? This modal means the number that appeared most. Frequency means the number of times something appear. The number of times something appear. So you can tell me boldly that the modal class is what? Is this 26 to 30, right? Because the frequency is 21. So if I want to get change in one, it will be 21 minus 8. Are you with
Yes,
me?
sir.
Because change in one means the frequency before this and this. Why change in two will be what? 21 minus what? 9. 21 minus 8 is what? That's 13,
Yes.
right? Why this one is what? This one is 12. So I would just see that in the space of seconds we've gotten an answer. L1 is the lower class bound of the modal class. That's 25.5 plus we have 13 divided by 12 plus 13, or 13 plus 12 times the class limit is what?
Right.
Is 5. Then you do your, yeah, you do your arithmetic. Okay, someone should just give me the final answer so you can
Okay.
move on. So funny enough, you solve the question. So I was using it as just practice. I don't know if the question. Okay. So I'm using my calculator here. So I hope you have a calculator.
Yes. Mhm.
Okay. Gotten my answer. Okay, let me know if you gotten your answer.
Is the answer 28.1?
Yes, that's the answer. Alright, great. So that's our answer, 28.1. Yes. So the answer is 28.1. Now let me check my question bank. Okay, we are done with this now. We've talked about measures of central tendency. Now, talking about measures of dispersion. We are talking about statistics. Then we are moving to graphs. Then from that graph, I would have to teach you quadratic equation, completing the square method. Do you know it? I
Partially.
don't know. Okay, we'll revise that together. I don't know why they're always bringing question on that particular method, like that. That's completing the square method. I don't know, but it's not difficult at all.
Uh,
You just know the
okay.
steps. So now let's talk about dispersion, standard deviation. What is standard deviation? What is the formula that guides standard deviation? Let me just tell you this. Okay, another measure of dispersion. Sorry, I forgot. Range. Yes. What is range? Quickly. Range is the highest number
Number
minus
minus
the
zero.
what? Lowest number. Exactly. So it's not highest frequency minus lowest frequency. It's the data we are talking about. The data itself. Please don't mix them up. So standard deviation is actually the root of variance. I don't know if you've seen this somewhere
I
before.
have.
You have to have this at the back of your mind. Yeah. So if you know variance or you know standard deviation, you can know. If you just know one of them, you are fine. So standard deviation is actually the root of summation of f bracket x minus x bar all squared. So the major thing is just knowing the parameters. Summation of f. So another major of dispersion I forgot. Okay, thank God it's coming. Mean deviation. So you might be asking, what is the purpose of having standard deviation and mean deviation? Are they not the same thing? Like, what is the wastage of time? Actually, because this thing, there are computer programs that run all these things, like that compute all these things. They are used by data scientists. So they noticed that that's the scientists that were bringing out the formulas and everything, that were doing the research. They noticed that standard deviation produced a better result when they are doing their analysis than mean deviation. What is mean deviation? You see that they are similar, but one is of squares and one is of modulus. Okay, so mean deviation is summation of x. Do you remember the formula? This minus this. So I know I told you that you can use the Fobigo table. Is allowed in the exam hall. But in case sometimes some things happen, unfortunately someone forgets something before the exam. So you just have to like have a backup. I'm not praying for that. So in case you forget something or not, you must know the formulas offhand, whatever. So what is this summation? Summation means, I'm sorry, I said summation. This modulus. Modulus means when you are doing your computation, let's say you have -5. The modulus of -5 will give you what? 5. The modulus of 3 will give you 3. It's always turning negative or positive numbers to positive. You get that now?
Yes.
So I need to know that means in this standard division, if I want to draw my table now, I'm trying to teach you how to use the formulas to draw table. If I want to draw my table, I must get my formula. Then my formula will guide my table. Alright. So we have we are going to have a table like this. We have x. We have you can't have by x or mean of x. The mean of x is gotten from what? F of x. You get. So when you get that, then you also have to do x minus x bar. Then you have x minus x bar square. Then you now do what? F bracket x minus x bar square. See that my table was guided by what I have here. Do you get that now? So we'll not be going into solving any question, but wait, let me check a question here. I think I have a question here that we can solve quickly. Sorry, give me a few minutes. Let me check. So we'll be solving a question any minute from now. So before that, is there any question before we
No.
start? Yes. Okay, okay. There's no question. Yes, I just remembered. I will give you like a brief of okay. I can see what you have here. Okay. I'll give you a brief of this. We have what we call statistical charts.
Okay.
Now, what is statistical charts? Can someone give me examples of statistical chart? I know these maths, but I just want to use it to this more English. Can nobody will ask you examples of statistical chart? No, solve questions. But I want to just you to explain something. So So give me examples. Let me hear. That means ways of presenting your statistics, your data. Okay, let me give you an instance. Pie chart is an example. That's one. Another one is bar charts. Another one is Instagram. So can you give me the rest? I'm sure I've not listed everything. Yeah, I'm waiting. Who wants to give me? Okay, so we'll move on. I was talking about statistical charts. I said let's talk about statistical charts quickly before we move on. So what do you understand by statistical charts? Give me examples.
Um,
So yeah, so example, I gave pie charts, line graphs, anything that can visualize your data, that can
oh,
make it visible.
bar charts,
Yeah. Yes.
histogram.
Yes. Instagram. Which one again?
Listen, what's the name? I can't really remember.
We have who give cups,
Oh yeah, oh give
right?
call.
Yeah, 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 they are part of it. Have I mentioned pie
Yes, you
charts?
have.
I don't. So, which one again? I think those are the major ones that comes out in the exam. And graphs. So line graph is an example. Line graph is just, don't mind the technicality in the name. It's just you have your y-axis, you have your x-axis, and they visualize the data. Like, let's say this is the frequency table. Sorry, this is the frequency table. This is the x. So you know that these what there's something you should notice. Have you noticed that the frequency is always on the y-axis? Yes, that's something you have to note about statistical charts. Frequencies are always on the y-axis because you want to show how big or how small something is. For instance, I was like taking a course today and I was checking, like, they are talking about customers review when you use a product, and customers are, they want to know, for example, you have a website and someone click on it and they want to know if the person really spent time on it. So they use the amount of hours the person use is written here, why the person that is using it, that's the exact data x. For example, let's say Dada spent 10 minutes on the app, on the website. It can be visualized like this, like in form of a bar chart. Do you get now? So let's say Titi used 15 minutes, you know it to be longer. Do you get that now? So let's say Shade used 30 minutes, like that. So this, like, for example, this is an Instagram. Why is it an Instagram? There are no spaces between them, and Instagram does not really have, like, Instagram is different from bar chart because bar chart is spaced. Number one, is well spaced in the middle. Number two, Instagram does start from like anywhere. It starts from where the lower class boundary starts from. Have you noticed that we use lower class boundaries as the x and what the frequency as a? Please try to note all this. Maybe you can write them in your jotter. For histogram, we usually use the frequency, right, and the lower class boundary. Now for O give curve, very easy. O give curve, what do we use in O give curve? In O give curve, we use upper class boundary here, and we use what? And we use frequency. Oh. Okay, so why did I stop? So I was talking about O give curve here. So for O give curve, we deal with cumulative frequency and upper class boundary. The cumulative frequency is always at the y-axis, while the upper class boundary is at the x-axis. Now you see that is a curve. Please note something. The difference between curve and line, to get full marks in your exam in case it comes out. Curve, don't use ruler. If you can get what is the name of this stuff, that we use for curves. French curve here, just remember the name, that has circles and many other things in it. So if you can use French curve, our advice, I don't know, do you know how to use broom? I don't. I've tried my best, I did not get it. So broom is not always problem. My broom is always looking like ruler when I use it. So I guess my best bet is actually the French curve. So please, the curve, not a line. You have to know that clean and clear. Alright. So cumulative frequency and upper class boundary. Alright. So for the cumulative frequency, alright, so you have something like this. Let's say the first data given to you, you are going to have something like this. You're going to have the data itself. Let's say you have 25 to 30, or let's 26 to 30, 31 to 35. The lower class boundary and upper class boundary can be 25.5, 30.5, like that. So ensure you are using the upper class boundary. Please know that, the upper class boundary. So let's say this is the frequency, then you must have a cumulative frequency table. What is cumulative frequency? Let's say, sorry, I think I have to make this bolder so you can get whatever we are talking about. So let's say, for instance, frequency here is 8, 10, 2, 15 and 3. The cumulative frequency will be, the first number here is 8, you write 8, you say 8 plus 10, that's 18, 18 plus 2 is 20, 20 plus this is, yes, 35, and here is 38. So this cumulative frequency, yeah. So you are dealing with cumulative frequency. Have you ever asked yourself that, why are we not using frequency? If you are using frequency here, it will not make sense, because the curve will kind of be going up and down, like it will just be going like moving lines and all those kind of things. But when we are using cumulative, it's going to like kind of grow. Let's say this is to here is a curve, this is to here, this is a curve, like this, another one is a curve. Let's say you have something like this, then a curve. Then we usually deal with percentile. We deal with percentile, quartile, semi-quartile, semi-interquartile, I mean. So let's just talk about that quickly, then we'll move on to other parts, to graphs. So I believe you've been able to learn one or two things from here.
Yes, sir.
Because I don't want us to waste our time on one topic alone, since it's not one topic we are just doing, like a crash and a revision class. So I was talking about quartile. I'll talk about those things, then we'll move on quickly. What is quartile? Quartile, from the word quartile, it means 1/4 of something. So you have lower quartile and upper quartile. Lower quartile means 1/4 times the cumulative frequency. You get, the upper quartile is what? It's 3/4 times the cumulative frequency. Then we have interquartile. From the word inter, is like you are saying Q3 minus Q1. Sorry, I don't mention this. This is known as Q1. This is known as Q3. Listen, there's something I want to point out quickly. That many people usually, like, will I say, they mistake it or they miss it out. Semi-interquartile is Q3 minus Q1/2. Now, once you've done all these your stuffs, that's not the final answer. This is where many people miss it. Like, don't think this can never be your final answer. It's not your final answer. For example, they tell you get the 58th percentile. 58th percentile means 50/100 percent, like 100% times cumulative frequency. Or they tell you get the median. Median means 1/2 times cumulative frequency. You don't just get it and just write number. For example, let's say the cumulative frequency is 200. You can't tell me that my upper quartile is 3/4 times 200. Then you now tell me, okay, the answer is 150. No, it's wrong. The answer is not 150. You have to go back to your whatever. Go back to your graph, cumulative frequency here, upper class boundary here. Then once you have your graph drawn in whatever way, then you trace it. The same upper quartile here is 150. Look for 150 on the cumulative frequency table. This is 150. Then trace it. You get, trace it, then you trace it down. This is when many people miss. Like, I've seen a lot of mistakes when, like, since I've been teaching people. Likewise, I've seen a lot of mistakes. People are always making mistakes. Please don't fall into the trap. Make sure, like, you have this set and done. Are you with me? So make sure that you have this intact. Tally marks. Okay, use tally marks for questions like this. All right, so let's move on. We've talked about statistical charts. Let's talk about graphs and quadratic equations. Let's talk about graphs and quadratic equations. So I'll rub up the screen now and we talk about graphs and quadratic equation. Hello, are you there? So we're able to get the tally mark part. Hmm? So I talked about tally mark and I said when you are doing statistics of this kind of nature, like you can see here evidently the numbers are just too many. Use tally marks for something like this. So for example, you write all the numbers you can see first. Then let's say this 65, you just put a 1 here. When you see 66, another one. You see 67, put 1 here. 64, like that. So once you've finished everything, see that it's very rare to make mistake in a scenario like this. Are you with me? So it's very rare. So this is like the best thing you are meant to do. This is the best thing to do. Alright, so we are moving on to graphs. I'm moving on to graphs, so I'll explain graphs just like this. And we'll also do quadratic equations. Maybe we should even do quadratic equation first. So let's look at quadratic equation first. So quadratic equations have been very common in your exam, and for quadratic equation we have like 4 formulas. We have the factorization method, or 4 methods, sorry. We have completing the square method, blah blah blah. We have formula method, or what some people call almighty formula, and we have the graph method. So now you notice that this completing the square is so common. The factorization to come out, but I think maybe the guess factorization is much more easier or something. So let's just do factorization for maybe those that might be watching this video one time or one day or whatever. So let's do the factorization. So for instance, you have x squared minus 8x plus 12 equals to 0. When you are dealing with factorization in quadratic equation, what you have to understand is that for me to solve this question, okay, let's take it as our number one question. For me to solve this question, I need to look for two numbers that when I multiply them, I will have 12, and when I add or subtract them, I'll have minus 8. Now in quadratic equation, you multiply this first one regarded as A, this is B, and this is C. You multiply this, the last and the first part together. This is the last and the first part. When you multiply them, you have 12x squared. Now look at two numbers that will give me 8. Okay, I can think, okay, I know that 6 and 2 should give me 12, and 6 and 2 should give me 8, but I can't use plus 6 and plus 2. It is wrong. Why is it wrong? I'm having minus 8. If I use them, I'll have plus 8. This is wrong. So I need to use what? I need to use minus 6 times minus 2. Good enough. Minus times minus will give us plus. 6 times 12 is what? Plus 12. So once we do this, we have what? X squared. So what you just have to do is that you replace this minus 8x in middle to two numbers. That's minus 6x minus 2x plus 12. That's why it's called quadratic. Quad, the meaning of quad, we have quadcopters, a lot of things that we have used, quadrangle, everything. Quadrilateral is always talking about 4. You can see now here we have 4 items, then you can group them in twos. That's the importance of factorization method. You group them in twos, so it's very easy to factorize. Factorize means bringing out what is common. When you are factorizing, you are dividing actually. So you are bringing out what is common. All right, so what is common here is x brackets x squared divided by x is x, minus 6x divided by x is 6. We have minus 2 common here, bring it out. Minus 2 divided by minus 2 is x. 12 divided by minus 2 is what? Minus 6. Then as long as these two can be the same thing, this and this, if they are the same thing, you're on the right path. Then you can just group them. So once I group this, I'll have x minus 2, x minus 6 equals to 0. Then I can have split them up. X minus 2 equals 0, x minus 6 equals to 0. Then you have x equals to 2 and x equals to 6. So this one factorization method, we'll be working with completing the square, which is very common in theory questions. We'll be working with that quickly. Yes, we'll be working with that. So while I rub up the screen, you can jot one or two things down. Sorry, I have to quickly do something. Okay, so I'm back. So completing the square method, that's what we are on. So we want to solve it with factorization method. So the two numbers, when you multiply 2x squared and minus 5, we give you minus 10x squared. So minus 5x plus 2x is what we are using. So you write them. You have minus 5x plus 2x minus 5 equals to 0. So once we group them, let's group this. So we group them, we have x common because no number can divide them. So I have 2x minus 5. Now here nothing is common, so just put plus 1 out. Then you have 2x minus 5 equals 0. So here we can have x plus 1 equals to 0, 2x minus 5 equals 0. Until when these two are the same thing, you can't do anything. If they are not the same thing, go back and check your work. That means something is wrong. It's not a correct equation. So once this one comes, it becomes minus 1. Then x is what? 5 divided by 2. Now I've used what is it called? Factorization method. I want to use completing the square. That's what we want to go to, so we can revise it with ourselves and learn something. Alright, so completing the square method. So completing the square method. Now the same question, we must get the same answer. I will have 2x squared minus 3x minus 5 equals to 0. Alright, so what is the first thing you do in completing the square? You divide the coefficient of x squared. You divide 2 by the coefficient of x squared. What is coefficient of x squared?
2.
The coefficient of x squared is 2. So I have 2x squared divided by 2 minus 3x divided by 2 minus 5 divided by 2 equals to 0. So you have x squared now minus 3 over 2x minus 5 over 2 equals to 0. Then what is the next step? Take the c to the other place, or cross the c over to the equals to sign. That's, you can just, let's just say cross the c, the coefficient c. You should get what I'm saying. This is a b c, the coefficient c to the other part, or instead of using the word other part, you can call it, the best thing using mathematics is the right hand side, RHS. So when I cross it over, I'll have equals to 5 over 2. What is the next step? The next step is the major step. Like, there are not much steps here, so let's just remove this. Though we know our answer, somewhere in our mind, that is minus 1 and 5 over 2. Alright, so moving on, you do something. Please listen carefully. What do you do? Write this same number back, then do a plus. What will your plus cover? Your plus will be, you are going to use b. You know, we've used a, which is 2. We've used c, which is what? 5 over 2. It is time to use b. So you say this b is 3 over 2. Don't take it with the sign. Times, multiply by 1 over 2, or some textbooks will say divide by 2. Then when you are dividing by 2, it means times 1 over 2 under our BODMAS principles. I hope I'm right. So then the equals to sign equals to this same thing, you write it, plus, repeat the same thing you just did here using your b. Your b was 3 over 2 times 1 over 2 all squared. Please don't forget to put the square. I'll tell you why we put the square now. Then just try to compute, try to make it simpler, like bring it together. 3 times 1 is 3, 2 times 2 is 4 all squared equals to 5 over 2 plus 3 over 4 all squared. So what is the next step? The next step is like you group them. What are you grouping? You are grouping the squares together. Now the two numbers that have squares here are x and 3 over 4. So you can bring them together. Don't take the square here, just bring the x. Now what will be the sign that will be in their middle? The sign you are going to pick in the middle should be the sign of your b. You are still working with our b. If your b is plus, you are going to use plus. You have to get that straight. If it's minus, you also use minus. So whatever your b is what you use. Here our b is minus, so I'm using minus. I'm taking this number 3 over 4. It's like something like a factorization. Then what is common between them? Square. I put square. Make sure you practice this after the class. 5 over 2 plus, we can compute this 3. You know, when you have square, it means everything is squared. 3 raised power 2 is 9. 4 raised power 2 is 16. Alright, so moving on. I can rub this off, right?
Yes.
Okay, good. So let me rub this off. So I have x minus 3 over 4 all squared equals to, the LCM of 2 and 16 is 16. 16 divided by 2 is 8 times 5, that's 40, plus this is 9.
Yeah.
Am I right? So you have x minus 3 over 4 all squared equals to 49 divided by 16. Now what do you do here? You square both sides. Sorry, square root both sides. So once I square root both sides, there's something you should know about square root. When you are doing a square root, you're always having plus and minus. Like the root of 4 is not 2, is plus 2 and minus 2. You have to have this at the back of your mind. Do you know why? Why? Because how do you get root of 4? You are trying to say x equals to root of 4. And for you to say x equals to root of 4, you are trying to say s squared equals to 4. Another quadratic equation, this thing means if I bring it here, s squared minus 4 equals to 0. And you know the drill. Once you have x squared minus 4, it means x plus 2, x minus 2. I hope you know this, equals to 0. So that's why you're always having two values. So once I do this, this will cancel this. I have x minus 3 over 4 equals to what? Plus or minus 7 over what? 4. So I'll leave you to solve the rest of the answer and you let me know the answer. So I'll be waiting. This one come here, so it becomes plus 3 over 4. So I'll be waiting for the answer. If you are done, let me know. So we'll move on quickly to something else. So are you done?
I didn't get the answer.
Oh, but like you saw my stuff. Like, do you continue from where I was? Yeah.
No.
Okay, started from the beginning.
Yes.
Okay, so where do you miss it up? So let me know.
I stopped at x minus 3 over 4 equals to plus or minus 7 over 4.
So minus 7 power. Okay, yeah, now you should get it from here. Should. Okay, just look at, maybe you just mix something up. Okay, I'll rub this off since you've written it. That's where I stopped. So you remember our answer is minus 1 and 5 over 2, right? If you remember vividly. Okay.
Yes.
So just look at it, very easy. Here you have x equals to, now this plus is going to be split into 2, plus 7 over 4 plus 3 over 4, or plus 7 over 4, sorry, that's a mistake, minus, yes, minus 7 over 4 plus 3 over 4. Okay, I have to admit someone. Welcome. Alright, so we are doing completing the square method already. So this x equals to 7 plus 3 is 10 over 4. Do you see it now? So you should get it. minus 7 plus 3 is minus 4.
I'm really sorry, sir. My phone went off, that's why.
Oh, I get, no problem. But
Minus 4/4. So x is equals to
yes, x equals to 5 over 2
5 over
or
2.
minus 1. So and then we can use solve completing the square method. So as you know, maybe we'll continue to the graph I want to explain, or I solve one more question before we move on. Are you there?
I'm here.
Okay. I said, do you understand completing the square method, or we should solve one more question?
One more question.
Alright, so
Sir, please solve one more question.
okay, let's do one more question. So do you have a question around? Oh wait, let me check my questions here. Let me see if I can pick one question. Okay, I think I'll pick a question here. Alright, so let's take a question. Still on completing the square method. Alright, so because of our time, we have to be very fast so we can do other things that we have to do. But if you have questions, don't hesitate to drop it on the group, please. Tomorrow is like the last day you have, so I'm not closing the group till after the math exams, so you can still drop your questions after the whole, you get, when you are reading today and tomorrow. That's why I'm not having a tutorial, so that you can, because you must have time to like revise on your own. It's very important. So let's take another question. So I have okay, let's see, we have 3x squared minus 8x plus 5 equals to 0. Good. Yeah, so these are second question. Now I'll start with the exact step I used. The first thing is to, okay, you can do it this way. Okay, the first thing is to start. You are starting with the c. Take the c to the left hand side, sorry, right hand side. We call it right, this is right hand side. So this is like ABC. Assume everything as A, assume everything here as B, or the coefficient, and assume the coefficient here as C. So the first thing is to take the C to the left hand side. So here will be plus 5 will become minus 5. That is done. Then the next step is to divide through by A. Dividing through by A means this will be 3x squared. You are dividing by 3 everything, that means of true, that's every single one of them, minus 5 over 3. So here this will cancel this. Let's say there is no number here, you don't have to do that method, you just leave it and move on to the next step that I will be teaching you. So here will be x squared, because if you divide by 1 you still have the same answer, so it's like a wastage of time, minus 8 over 3x equals to minus 5 over 3. So are we clear with this?
Yes, sir.
Now moving on to the next stage. Very simple step, like we did, it's just like 4 steps or 5. So the next stage is we have dealt with C, we've dealt with A. The next thing is to use your B. Multiply your B by 1 over 2. Multiply B by 1 over 2 and you square it. What do I mean? Like I have x squared minus 8 over 3x, you add it plus 8 over 3 times 1 over 2 all squared equals to, you do the same thing here, minus 5 over 3 plus 8 over 3 times 1 over 2 all squared. If you notice something, I only picked it without the negative sign. That's what you should notice. So I'm just picking just the B alone, then I multiply by 1 over 2 I squared it, equals to this c that was there before, the same thing, I added the same thing, the plus sign. If you notice, 8/3 times 1/2. That's all. Then just compute means like multiply, make them better. This will be 8 times 1 is 8/3 times 2 is 6 all squared, equals to minus 5/3. The same thing, 8/6 all squared. Now the next step is to group them, is to group the squares for the left hand side. This is the left hand side. Left hand side is the one here. So group the squares. Now these two things are having square, you pick them. This is x. Which sign are we going to use? We are going to use the sign of the b. As I said earlier, if the b is minus, you are going to use minus. If it is plus, you use plus. The sign of the b is what determines the sign that will be here. You have to remember that and take note of that. This will be minus. Now, as I've said, pick this 8/6 is factorization, pick what is common, then square goes up. That's the method. Then this one does solve it, finish. 5/3 plus 8 square. Remember, this square is for both of them. If I'm you, I don't like stress, I just divide. This is 4/3, so this becomes 16/9. Are you with me? So I don't like to be using big numbers, piss me off. So okay, don't let me rub off this thing. Don't let me rub off the real question. So hope you're following. So 9 is here. Sorry, I think I omitted that. Then move on, work with that right hand side, let it be complete square. We can make this 4/3. I think let's do it 4/3 quickly. 4/3 all squared equals to, now I have minus 5. What is the LCM of 3 and 9? Is obviously 9, right? Minus 3 times 3
Yes.
is 3. 3 times minus 5 is minus 15 plus 16. So we have x minus 4/3 all squared equals to 1/9. What do? You square root both sides. Square root both sides. You see that we are already done. So the major steps are, take this one to the other side, divide all through by 3. After doing that, add it, then multiply the coefficient of b times 1/2 all squared. Do the same thing at the other side, then group them. After you've grouped them, continue your computation. So here you square root both sides, as you said, x minus 4/3 all squared equals to root of 1/9, plus or minus. I told you that when you are dealing with root, it's always plus or minus. Always, don't forget that. Always plus or minus. So let's move on. So what will be the root of 1/3? This we cancel, this will be square root, we cancel root, we cancel square. I have x minus 4/3 equals to square root of 1/9 is plus or minus 1/3. Then collect like terms, take this one over here, 1/3 plus 4/3, right? Simple. X will be equals to 1/3 plus 4/3, or this means plus or minus, so you pick the minus. Minus 1/3 plus 4/3. So someone should tell me my final answer so we can move on. And if there's any question, you let me know. Yeah, I get the final answer. What is the final answer?
Um, 5/6 or
Is it by
1/2.
it's not by over 6, so check again. You're adding the 3 plus 3. No, you pick one, LCM, don't forget.
Oh, yeah. 5/3.
Yeah,
Mistake.
and what?
And 3 And 1.
Yep, and 1. So 1 plus 4 is 5/3, or minus 1 plus 4 is 3 divided by 3, that's 1. Alright, so that's our final answer. So before we go, we are still solving questions. We should be done by 6. So aside that, let me just give you an overview of graphs. Is there any question before we move on? So I'll give you an overview of graphs.
No.
Okay. So after that, we'll solve some modulus and probability questions. I promised that before.
No, sir.
Okay, so don't worry, I'll try to just bring out the video. I'll try to. I stopped some recording and I continued. I'll just try to put them together. So okay, so let's talk about graphs very fast, like in the space of 5 to 7 minutes. Just talk about graphs. Now I said I've talked about the OGIF curve in statistical charts. We've talked about so I want to talk about algebraic graphs, since we are still in the spirit of algebraic graphs. So what are algebraic graphs? Algebraic graphs comes in two forms. We have like the U and the N. U means it is positive. When you have x squared minus, let's say 3x plus 2, these are your graph will be. It means when it is at 0. What is at 0? When it is let me just give you this understanding, very, very useful. Like, I don't know if you guys are in science, whatever science stuff you be doing, because there's now you know want to apply maybe maths or physics, one way or the other, or chemistry or whatever, you always deal with graphs. So this thing means, let me come again so it will be better. It means y equals to x squared minus 3x plus 2. Why we are always saying do quadratic equation when y equals to 0? We say x squared minus 3x plus 2 equals 0. What is actually equals to 0? It is actually y that is equals to 0. That's what is equals to 0. So like, how can you know your answer when y is 0? It means in a graph like this, when y is 0, my answer, this is how it will be. It will fall between what? 1 and 2. I hope you know that the answer for this, x squared minus this, is x equals to 1 and 2. You should know that. So this is equals to 1 and 2. It means when y is 0, this is where y is equals to 0. This is x and this is y. At this point, y is 0. When y is 0, it will be what? 1 and 2. If I now want to say x squared minus 3x plus, let's say for instance, they gave us, I've seen some questions in WAEC, they will say find when y equals to, find when you have x squared minus 3x plus 3. Can you tell me what are you going to do? Equals to 0. Are you going to draw a new graph? No. What do you think you should do in a case like this? You started analyzing graphs, so these are the most important parts that you need to understand. What do you think you should do in a case like this? You know, have you seen past question whereby they will give you this exact question? I'm talking about theory, and they will not say you should find this in the graph. If you know, they're always using find it in the graph. That means you are not solving it with the other things I just told you here. So what do you think you are going to do? Okay, let me teach you something very, very powerful. So we have, this is x squared minus 3x plus 3. You notice that we said x squared minus 3x plus 2 equals to 0. For this thing to be 2, something has happened. We've added 1, am I right? To make it 3. So how do we add 1? We said our y is equals to minus 1. This is logic. Then I bring this one here. This one comes here, it becomes what? 2 plus what? 1 equals to what? 0. You know, 0 comes here when there's nothing, you fill it with 0, right? So it becomes x squared minus 3x plus 3 equals to 0. That's how we add this. Now, how are you going to do this in a graph? It means your y is equals to what? Minus 1.
Minus
Yes,
1.
what will I do? I'll look for minus 1 on my graph. So in this thing, let's say here is minus 1. Then I'll draw a long line. Then I'll trace it back. I wish you can zoom this now. I'll trace it back to here. This is my x1. I'll trace it back to here. This is my what? X2. Do you get it now? That's how you work with simultaneous equation graphs. So, for example, they said y equals to, let's say it is minus 3. Okay, let's say you have, I'm looking for a very good example. You have x squared minus 7x plus 10. And you know, you've done your whole graph. Remember, it's always going to be in a U form. If it is minus, it's going to be what? In an N form. Remember, am I right? So in this case here, the answer is actually 2 and 5. Let's say they said get this in equals to 0. You just trace them on the graph. After you've plotted your graph, how will you plot your graph? Please listen to these tips. When you are plotting your graph, show your workings. Don't just write WAEC exam without showing workings. Your small solving, solve it somewhere in the booklet, like, but don't solve it between those lines they say do not solve it somewhere outside, so that they will know that okay, this guy did not copy from maybe his partner or from other guys. Because I remember when I was in secondary school then, there was a lot of malpractice, so the score has been tagged for malpractice, so the result was always very, very bad every year. They always catch me for every year, so they've tagged the school very bad. So the marking is always, I don't even know if they mark or they just throw the paper away. So I remember then, so I got the scope that since the malpractice rate is very high, I need to like distinguish myself from others, because I will not want to write the exam the second time. So for example, it's logical, you have to be very, very smart. They gave you want to do 5 plus 3, and you know that is 8. Sometimes I purposely write 5 plus 3 equals to 8 somewhere inside the answer booklet, just like up somewhere, so the person will see that okay, this person own is different. It's actually solving everything he's doing. It's different from other. Try to show your workings both inside your worksheet and somewhere outside your worksheet, because it shows that this person is different from the rest, and the result was good. Even though the school is tagged bad, the marking scheme is very strict for us because of the reputation of the school. So that's why it's always good to show your workings. Very important. I will not say more than that. So now they said x squared minus 7x plus 10 equals to 0. So you can easily find it on the graph by doing this. But now let's say you now have, someone should tell me this. Okay, so I will know if you've gotten what I'm saying. If I have, they now tell you find x squared minus 7x plus 8 equals to 0. Someone should tell me, how am I going to do it? This is y and this is x. Yeah, quickly, I'm waiting. I said if you have, for instance, you have x squared minus 7x plus 8 or whatever. Now how will you do this? Quickly. This normally, the y they gave you in the question was x squared minus 7x plus 10. You know the way they do it now in WAEC, they will give you table. Let your x be, maybe here will be minus 1. They will say for minus 1 less than x of, let's say, 4. Then you have to start from minus 1 to 4. Please note your inequality sign, very important. If you are given like this, it means x is greater than minus 1. You don't start from minus 1, you start from 0. Your table starts from 0 and it ends at 4. This thing means less than, this one means less than or what, equals to. So once you've done your table, you now say you should make this equals to 0. Now for example, I now said okay, if they now say x squared minus 7x plus 8 equals 0, that means your y is no longer 0. Your y is now 2. How did I know it's 2? It's logic, as I said. This is 7x plus 10 equals to 2, because if when 2 is subtracted from 10 and a half, 8, 10 minus 2 equals to 0 here, then my x will be minus 7x plus 8 equals to 0. What has happened? Because of my y is now 2, then the new formula becomes what? X squared minus 7x plus x. So you look for 2 here on your graph, look for 2, then draw the line of 2. Is a straight line. Do you get? When you draw the line of 2, look for it like from here, trace it down. You have something like this, trace it down to the 0 part, then you get your what? You get your answers. So it's as easy as that. Is there any question? So move on quickly.
I won't deny it. I don't understand it. That's because I'm the network is having.
Oh, okay. All right. So okay, let's do something quickly. So is your network stable now?
No, it's not still stable.
Okay, but you'll be able to watch the video. I will, so you guys can download it. Maybe in midnight or anything.
Yeah.
You get? So alright, let's solve question on probability and modulus, so we can call it a day from there. I know on the group we've done several bearing and distance, longitude and latitude, circle geometry, so that's why I'm not repeating them, since I'm kind of doing what we did not do yesterday. So if you need tutorial or something on circle geometry, you can check the YouTube channel or just check the group. Like, you always get one of it from this Fifth Learn YouTube channel or from the WhatsApp group you are in. So you always see, so you have a lot of libraries of things, voice note and solution. So quickly, let me look for a question on probability and modulus, so we quickly solve, because I'm saying it surface a lot. Okay, give me a few seconds, let me check. Hope we still remember compound interest.
Yeah, I still remember that.
So don't forget those stuffs, are very important. Okay, I've seen the question I have here. Sorry, let me see. Okay. Okay, so this will not work. Let me just paste what I have. So let's look at modulus, and then we deal with the other part. So we don't actually need everything here, but I was trying to cut. It's taking my time, so I just have to paste it here. Okay. So, oh sorry. Let's just move on. So here we have an operation. I'm dealing with C question 11C. So this, as you can see, this is WAEC 2015 question. Yeah, we have an operation giving us your hash. Are you there? On it, okay.
Yes.
On a set 1, 3, 5. So the question now says your set X is equals to 1, 3, 5, and 6. If your M times your N, or operation, I'm not using the word times, it should be operation N, is M plus N plus 2 modulus of 7. See that they're trying to add a binary operation you did in further math and modulus here together. They said what is M and N if is an element. This means an element of, is like a Greek sign, an element of X. So we are going to draw a table. Do you know how you draw a table? You just list this thing out, very easy. Here you have 1, 3, 5, 6, 1, 3, 5, 6. Remember what I told you about modulus? If they give you modulus of 7, it means whatever you get must not be greater than 7. If it's modulus of 8, whatever you get must not be greater than 8. How do you ensure that? You ensure that by subtracting 7 from that number. If the number is very big, like 28, or sorry, let's say 29, you continue subtracting 7, or you subtract multiples of 7. For example, multiples of, I can't use 7, I will not be wasting my time. I can use, like, multiples of 7 is minus 28 is close, so I will have what, 1. If it's 28, I will have 28 minus 28, that was 0. If it's 27, I can't use 28, I can't have negative, it's not possible. So I'll use something lower than that, that's minus 21. So I have what? I will have 6. Do you get that? So this is the operation. 1 plus 1 plus 2, that will give us 4. 1 plus 3 plus 2, 6. 1 plus 5 is 6 plus 2, that's 8. 8 minus 7 is 1. Do you see it now? 1 plus 6 is 7 plus 9, that's 9. 9 minus 7 is 2. So the game continues. 3 plus 1, like that. So this will still be 6. 3 plus 3 is 6 plus 1, that's 8. 8 minus this is 1. 3 plus 5 is 8, 8 plus 2 is 10, 10 minus 7 is 3, 3 plus 2 is 9, plus 2, that's 11, 11 minus this is 4, 5 plus 1 is 6, plus 2, that's 1, 5 plus 3 is 8, that's 3, 5 plus 5 is 10, 12 minus 7 is 5. So we get the logic. That's why I'm kind of fast. 5 plus 6 is 11, 11 plus 2 13, this is 6, 7 plus that's 2, 6 plus 3 is 9, plus 11 4, 11 13 6, 12 14 0. So that's this our, you've drawn your table, you've gotten your answer. Then use your table to do 3 multiplied by n giving you 3. What is that number that 3 will operate and will give me 3? This is 3. It's operating something to give me this 3, and that's what 5. So I'll say my n equals to 5. As simple as that. We've done this before. This is n operation, n is 3. That means if the same numbers are the same and it's giving me 3, which number is 3? And you have the same number, it's giving us 3. Check the table to see if you can find something like that. Have you seen it?
To see if you can find what?
Our question is n operation, n is 3. So is there anything on the table that gives us 3? Check my work. There's no that 3 here. There's no that 3 here. So are they actually right? Just check, cross check this quickly if they are right or wrong, so we can know. Should be bringing all to close. So I don't know, maybe it's a mistake from there, but we get the logic, right? That's the major thing. So that being said, let's move to probability. So is there a question?
No, sir.
Okay, so because of our time, let's move to probability quickly so we can move on. Don't worry, I don't know why network is bad, and the network is perfect here. Or the rainfall in your street today. Okay, so probability question. Now talking about probability, so that's why we have to come early to class. If you have been earlier, we have some time. Now it's past 6 already. I need to be somewhere else. So when we're talking about probability is just the number of required outcome divided by the number of possible outcome. But I was seeing some questions here. That's what made me to, let's see, okay, let's check these probability questions. Okay, let me just write it here. For example, I saw questions like with data. Not this kind of question. I don't know if you've seen it before. Here is X. Sorry, I would have used the other tools, but because of time, that's why I'm not using the right tools. I mean, there are some tools I'm meant to use to draw this, but time is not aside, so I'm not able to do that. So okay, let's say they gave us here as X. Here is 6. Oh, so I wrote Y here. It's not meant to be Y, it's meant to be a frequency. This is like a median table actually. This is like 3, 2, this is like 8. So you know, they told you that, okay, for example, the mean is X and is equals to 5. I'm just giving you an instance. You get me now? So let's say the mean is 5. I'm not solving anything here. The mean is 5. And when you solved it, do you know how you can get your X from here? Can someone tell me? I hope you've seen questions like this before. They're actually very easy. When you multiply this one, the f of here is 3, 2 is 2, 3 is 6, 4 is what? X, and 5 is what? 8. Once you multiply this, 1 times 3 is 3, this is 4, this is 18, this is 4x, and this is 40. If you add everything together, let's say our x here is okay, I will not use 5. 5 is not a good answer to use. Let's say our x is 3.5 for instance. Okay, let's solve this quickly. So you know, by x equals to summation f of x over e of f. Alright, so summation x now is, okay, instead of using 3.5, let me use 4. I just formed the question, so I pray it's perfect because of our time. I can say 4 equals to summation of f of x is everything here. 3 plus 4 is 7. 7 plus 8 is 25. 25 plus 40 is 65. 65 plus 4x. You can't add 4x. You just leave it on its own. 3 plus 2, 5 plus this 11. This is 19 plus x. Then you multiply. Once you multiply, what did you have? You have 4 bracket 19 plus x equals to 65 plus 4x. I'm sorry, I will not take this place as x. Let's take it as 3. So we can have something that is making sense. So this is 3 now. So here is 3. 3 times 19. 3 times 19 is 57 plus 3x equals to 65 plus 4x. So I have here as okay, sorry, I'm just tweaking things here because it was not really planned. I just used any number. So let's say our number here is 1, for instance. 5 times 1 is what? 5, Abby. So I have 25 plus 5, that's 30. So you can just go through it. That's why it's a video. This 30. So here has been changed to 3.
Minus 1.
Yeah, sorry, you can't get minus. That's why I'm changing everything. Do you get what I'm doing now? So I've changed the values now to here is now 3, here is 1 now. Those are the major changes I made. So I have 3 bracket, this is what 57, right? So I have 57 plus 3x equals to 30 plus 4x. So 57 plus 3x will be 7 minus 30 equals to 4x minus 3x. So x equals 27. This is not actually a good number, but it's just something to just work with. So let's say here x is now 27. Our new answer is now 27. Just for instance, here is now 27. You now say get the probability of, let's say these are marks of people in a class, of someone having less than 2. How do you do? That's where I'm going to actually. Less than 2 means it is not up to 2. The only number less than 2 is 1. So I'll say probability of less than 2, or let's say less than 3, will be probability less than 3 is 1 and 2. That will be 3 over this frequency. That's how I do probability of frequencies. That's what I just want to point out. 3 divided by what is probability of everything here? 3 plus 2 is 5. Without probability, 3 plus 2 is 5. 5 plus 6 is 11. 11 plus 28 is what? 39. So that will be 3 over 39 plus 2 over 39. Then you add them. What do you have? 5 over 39. If they say what is probability of people getting 4 marks in the exam, the same steps you are going to take. 4 mark is 27. That will be 27. Probability of someone getting 4, x equals to 4, will be what? 427 over what? 39. Don't make mistake and use this x. You get? Don't make the mistake of using the x. You have to use the frequency. Are you with me? So that's just all I want to point out. Alright, so I think, is there any question before we bring the class to an end? Any questions? I bring the class to an end right now.
No.
Alright. What of do you have a question? I think the network is still bad. So if there is no question, alright, thank you very much for joining the class. We'll see next time. So if you have any question, you drop it on the group. You get now? So drop your questions. I'll try to make the video available today. I'll try my best before night. Alright, so you can end the class now. Goodbye.
Thank you,
Yeah,
sir.
you're welcome. Yeah,
Bye.
bye.